Alright, this is our drill press. It's used for drilling holes and stuff. That's about it. We're going to start by going over all the parts of this, and then we'll go over how to use it safely. This top box is full of a bunch of pulleys and belts. This is called the belt and pulley housing. Now up top we have a bunch of pulleys and belts. Back here's our motor. When we turn on the machine, the motor actually only spins this guy. But this guy is connected by a belt to this pulley is connected by a belt to this pulley. The reason why we have so many pulleys, it allows us to change the speed of the drill press. If we move the belts up or down, we can make it spin faster or slower. If you're drilling big holes or holes in metal, usually you want a slower speed. There's more torque, there's more rotational force there, and it's less likely that you're going to heat up a bit and ruin its heat treatment. Basically, you don't burn up a bit. If you're drilling through wood or drilling tiny holes, it's really not necessary to have a slow speed, so you can crank it up to a higher speed by moving these belts. However, most of the time shops just set this at like a medium speed and call it good. It'll work for wood or it'll work for metal. But if you're going to be drilling like a lot of large holes, then it's probably worth slowing the entire drill press down. That way it's easier on your motor and probably easier on your bits as well. If you ever are messing with the belts in here, unplug the machine. You don't want to accidentally turn the machine on and get your fingers rocked by this machine. It's not worth it. Just unplug it. That way you know that there's no power in here and you can safely move the belts. And when you're not messing with it, keep this closed. That keeps dust and dirt out of there as well as fingers. So you know the belt and pulley housings right here. The motor is back here. That's what does the spinning. Right here we have two on-off switches. This top one does nothing because it's connected to a light bulb and the light bulb is burnt out. This guy is what turns on and off the machine. This spinny thing is called your chuck. That's what holds your drill bit, and your drill bit is what actually does the cutting or the drilling. Up top, this is called your spindle. The chuck can actually come out of there. It's just press fitted up there. The spindle holds the chuck. So if for some reason you broke the chuck or you needed a different one, you can actually pop it out of there. The spindle, which is right here, will stay there, and then you can shove a new chuck up in that hole. Now we need to be able to lower or push the drill bit down into our material, so we need to push the chuck down. To bring the chuck down, you're going to pull on, this is called the Quill feed lever, and that's going to bring your chuck and your drill bit down. I currently have this guy set to stop so that I don't drill into my wooden table. This is sacrificial, meaning it's eventually going to be drilled into, and that's okay. But when you can, try to prevent yourself from drilling into it. Now, how do I get this to stop at a certain height? Well, we're going to talk about the depth stop now. The depth stop is a threaded rod with two nuts on it. There's a bracket right here. When I pull down, the nuts hit the bracket, and that prevents me from going any deeper with my cut. This is adjustable. If I want to be able to drill deeper, I'm going to bring these nuts up to the top of the rod, and I can go pretty deep until I hit those nuts. And if I need to make a shallower hole, I'll bring them closer to the bottom of the threaded rod. Now, why do I have two nuts on this rod? Well, when the drill press is turned on, it's going to create vibrations, really tiny vibrations. And if we just had one nut, those vibrations would actually make the nut move up or down this threaded shaft. And I'll prove it to you. So you can see this guy's moving just a little. And while it's not moving a whole lot, if I'm drilling for say 2-3 minutes, it's probably going to make 3, 4, maybe 5 complete rotations, and that's a lot of depth. That's going to mess up my cut. But whenever I tighten two nuts against each other, I'm twisting them in opposite directions. It's actually going to lock them together, so now they can't move. It's even difficult for me to loosen with my fingers. And when I turn on the machine, there's no movement there. I'd have to physically come in here. And loosen them for me to adjust these guys. This table right here is called your tilting table because you can tilt it. I've never had a need to tilt it, but I'll show you how to tilt it if you need to. Underneath the table, I would loosen this guy, and then on this side of the table there is a gauge and I could twist it to whatever angle I need. It looks like I can go 45 degrees either way. Sometimes you might need to drill into a piece of wood that is taller than the distance between your table and your chuck, and if you have a big drill press like this, you're in luck. We can actually move this table up and down using this rack and pinion. That's what it's called. And when you have your table set to the right height, it's a good idea to clamp it in place using this lever. That way it's not going to move up or down on you. The last part of the drill press we haven't talked about yet is this pole back here. It's called your column. It's pretty simple. To drill a hole, the first thing you need to do is figure out how to chuck up your drill bit. Right now, the drill bit doesn't fit in there. You're looking at the underside of the chuck right now, and you're going to see there are three. They're called jaws. We need to basically twist the chuck to the left to open them up, and then we should be able to fit our drill bit in there. When I stick the drill bit in the chuck, I'm inserting the drill bit up until I just meet these flutes. The flutes are the spiral part of the bit. Right there, that'll work. Then I'm going to take my chuck key. It's probably sitting on the table, the tilting table somewhere on there. You're going to notice there's a peg with some teeth on it. Just find a hole in the chuck, stick the peg in the hole, then you're going to rotate it to the right. Now I like to spin the bit while I'm doing this. That helps me make sure that it is centered, and I'll explain to you why that's important in a second. We're going to tighten this guy, just finger tight, not trying to break it, but giving it a good tighten. Then we're going to come over to the next hole, give it a tighten again, shouldn't move a whole lot, and we're good to go. Now when I spin this guy, it should spin true, meaning the drill bit shouldn't really appear to move, right? It's staying in one place. It just kind of looks like it's there's a spiral rotating. If there's a wobble, and by wobble I mean this. This is what a wobble looks like. This is an exaggerated wobble. Basically the drill bit is not seated in the center of the chuck. It's been tightened off center, and so it's spinning off center. When that happens, just loosen the chuck, reinsert the drill bit in between the jaws, and I like to spin it like this so I know that it is in the middle of the chuck. Keep spinning, spinning, spinning. Okay. Tighten it. Come on over to the next hole. Tighten it. Give it a test spin. Yeah, nice and true. No issues with that. And another serious reminder, make sure that that chuck key is taken out of the chuck, set it on the table before you start drilling. Because what will happen, I couldn't tell you how many times this has happened to me. I leave it in there, I turn it on, and this thing gets whipped out of there at like a ridiculous speed. This is a heavy chunk of metal. This will crack teeth, I promise you. I've been fortunate, I've never been hurt, but it's definitely possible. Take that chuck key out of the chuck, set it on the table, or else someone or something, some machine is going to get hurt. Now we're just about ready to drill a hole, but we have to talk about safety. One, make sure you have no loose clothing, no long hair. If you have long hair, tie it back, because this guy is spinning with a ridiculous amount of force, and if anything gets caught in that, it's not slowing down, it's pulling you into the machine. You also need to worry about your workpiece, because your workpiece, right now it's not connected to anything, and if we're drilling down into this guy and then we let go, the drill bit is going to catch on our workpiece and it's going to fling our workpiece around really fast. It could possibly break the drill bit, fly back and hit us, or it could just spin around really fast and smack us. Ask me how I know, because it's happened to me. So we need to figure out how can we safely support this so that it cannot rotate. The easiest thing to do is use the column as your support, because the column's not moving, but this guy is not long enough to reach the column, so we're going to attach a clamp to it. Now I can actually drill, yikes, I can drill anywhere I want on this board, and my clamp is going to be in contact with that column, so that if for some reason I let go of that workpiece, well, the drill bit's rotating the workpiece that direction. It can't go past that column. It's going to hit that column and it's going to stop. It might mess up my workpiece, but at least it's not whipping around in a circle and possibly hurting me. Now before you drill a hole, it's a good idea to poke a little kind of starter hole with an awl or with a center punch, and that's going to give your drill bit a place to get started. If you don't do that, usually the drill bit will kind of walk on you, meaning it'll go around in circles and not drill right where you want it. But if you give it a little starter hole, usually it stays on course. It drills exactly where you want it. So make sure that your support, however you supported the workpiece, is against that column. Your drill bit is lined up perfectly on that starter hole, and your finger should be about 4 inches away from the drill bit. You don't have any long hair, baggy clothes, strings, gloves, nothing like that is anywhere close to the drill bit. Hey, we're good to go. We're going to turn it on, pull down on the quill feed lever. Now in drilling deep holes, especially, it's a good idea to almost pump the drill bit or bring the drill bit out of your workpiece. That's called clearing the chips. Basically, these flutes bring up the wood dust, the sawdust, the wood chips. Sometimes it can get clogged, but if you bring it outside of the workpiece, usually they just fly out of there, and then you can bring the drill bit back down and it can continue to cut wood. Now, you shouldn't really touch the drill bit after it's been in wood. There's lots of friction, lots of heat in there. I just drilled for 5 seconds, so I know it's not going to be too hot. All right, so I'm going to drill another hole, and I'll show you that pumping action that I'm talking about. Pretty simple, right? It's also a good idea, make sure that this surface is clean, free of like sawdust and wood chips, because if they get underneath your workpiece, they can tilt it at an angle, and then you're drilling a hole at an angle when you don't want it. So make sure the work area is clean, make sure your workpiece is supported against the column, and make sure you don't have any loose baggy clothing, long hair, strings, gloves in the way, because you can really get hurt that way. All right, that's all we got.